Well, we are early, right at time. So Eldert is prepared, I see, and he looked great. He looks really great. I like your background. Yeah, just give the audience a little of introduction of yourself, and then just continue. Feel free. It's your stage. It's free, and yeah, I'm really excited, as I said.
Let me start by sharing my screen. There we go.
By the way, it's recorded, so if something is just
Perfect.
against that, then just raise hand, and all the others that are joined after we started and discussed about the recording or not, if you are not a friend of being recorded, then just hide away.
So first of all, thank you for having me today. So I'm going to talk today about Azure Service Bus and how we can engineer for performance and throughput. Before I go into the topic itself, though, let me give a quick introduction of myself. I already see some familiar faces, but for those that don't know me, I'm Eldert Grootenboer. So I'm the program manager for Azure Service Bus. So I joined Microsoft about a bit over a year ago now. I used to live in the Netherlands where I worked as a consultant, moved over to Microsoft, moved to Vancouver. Hopefully end of this year, actually to going to Seattle, going to the mothership. But yeah, so as a program manager, basically what my job is basically making sure our customers are happy. So my job consists of talking to our customers, talking to the community, explaining what we are doing, why we are doing certain things, but also getting your feedback about what you like, what you would like to see. So, and today I'm going to talk about performance. And so I'm going to explain how you can get the best performance out of Service Bus. But I'm also looking for your feedback. So if you have any feedback after this session, please do contact me. You can always reach out to me on Twitter or on my email. I will also share them again and it's a final slide. So if you have any question during this session, please let me know. And why am I talking about performance today? So basically, I've been working with a lot of different customers, and some of our customers are really big customers, and one of them is actually a cryptocurrency broker. I'm not going to name names. We don't have any marketing contracts with them, so I cannot name names. But they're a very large cryptocurrency broker, and they contacted us a couple of months ago saying that they are moving to Azure, and they're looking for a message broker that can handle high throughput. And so when we start talking to them, what they meant with high throughput is about 100 megabyte per second. So for us, this is quite a big throughput. So to give you a bit of an idea, so at the moment we do about 2 megabytes to 4 megabytes per second per message unit. So message unit is basically your compute power that you get on Service Bus Premium, and it gives you some CPU, some memory, some other resources. But so we do about 2 to 4 megabytes per second on that kind of throughput. So 100 megabytes per second is quite a heavy throughput. And so we started talking about, okay, what is your scenario? Why do you need this? And basically what we found out is that they need this like 1 megabyte per second. They really need this. And so we are now working with them to get more performance out of our current MUs, but also working with them on best practices, etc. And so today I will be sharing a lot of those best practices that we already have, and also talk a bit about what we are working on to going forward to give better throughput. So what can you expect today? I will start with a quick introduction of Azure Service Bus. I'm not sure if everyone here knows about Azure Service Bus. If not, just a quick introduction so we're all on the same page, so we know what the service is. Then I'm going to talk about a couple of upcoming previews. So some things that are going to private preview pretty much in next week probably. I'm going to talk a bit about what has been recently released. So what we released in the last couple of months. And I'm going to talk, of course, about how can you optimize your performance. So with that, let's start with that quick introduction on Azure Service Bus. So Azure Service Bus, what is this? What is Azure Service Bus? So first of all, it's a platform as a service, queue and pops up message broker. So we are a message broker, so you can send message to us with high reliability. We have queue and pops up support. So queues is basically you put something into a queue. You have one or multiple producers. They put something into a queue. You have one or multiple consumers. They pick the message up from the queue. First in, first out. Each message goes to a single consumer. They can either receive and delete that message. So basically they receive it, and from that moment it's deleted on the queue. So they're now in control of this. Or they can do a peak lock on that message. And when they do peak lock, it basically means that consumer gets a lock on the message. It stays on the queue though, but it's locked to them. So they have a lock on that. They process the message. If they're finished with the message, they complete it. It's get removed from the queue. But they can also abandon it or defer it. And when you abandon the message, it basically becomes available on the queue again for the next consumer. And this might be because your consumer could not handle this. The consumer itself might have an issue. It might be an issue with the message. Basically, you can keep the message on the queue and process it again later on. Of course, this is all platform as a service, so that means that it's fully managed. We take care of the infrastructure for you. We take care of everything that you need, that you don't need to worry about. So you can just focus on implementing the solution without having to worry about all that underlying things that are there. We are AMQP 1.0 compliant and JMS 2.0 compliant, which means that if you have any AMQP system, you can just talk to us. So for example, Apache Cupid is something that we use quite a lot. When you're not using our SDKs, you can use any AMQP provider. We're also JMS 2.0 compliant. So JMS is very big in the Java world. It's a Java message system. And so, for example, if you are currently working with ActiveMQ or maybe with IBM MQ or what others are there, like typical EMS, so they all use JMS. And so if you want to, you can basically just switch over to Service Bus to basically import our package. You change 2 or 3 lines of code, which basically your configuration, your endpoint, and your factory setup. And at that moment, you can just talk to us using JMS. So very easy to switch over. And so we have quite a few customers, for example, that are coming from IBM MQ over to Service Bus, just because IBM costs an arm and a leg. So moving over to Service Bus, they save a lot of money, but they don't have to make any changes to their existing code. So it's very easy for them to migrate. We have a polyglot Azure SDK, so we have support for many different languages. Of course, we have the .NET, but also Java, JMS, JavaScript, Python, Go. So we have a lot of different languages. It's all part of the Azure SDK. So we actually have a whole team that's working on Azure SDKs. We used to actually do this in our own teams. So basically, the Service Bus team would handle the Service Bus SDK. The storage team would handle the storage SDK. But at some point, Microsoft decided that we need to change this because each team implemented it their own way, meant that there was not a lot of consistency. It often did not adhere to the best practices, especially when we went out to .NET, out to the net. So we now actually have an Azure SDK team that handles all these different SDKs. They know the languages through and through, so they know exactly how each language works, what are the things that you would expect there. There's a lot of consistency through the different service SDKs now. And so you basically can come with any language that you want, so you don't have to learn .NET. If you're already on a different language, we probably have an SDK for that. Of course, we are industry leading our reliability and availability. So actually, our single core principle is we will never lose any messages. And so that means that when you send a message to Service Bus and you get an acknowledgement back, that message is on Service Bus until one of your consumers says, hey, I got the message, you can now delete this. This is our, like we have 10 core principles, but this is our number 1 core principle, that we will never lose any messages. So that's that reliability. Our availability is also very important to us. So if you are using Service Bus or most of the other services on Azure actually as well, you'll always have 3 copies of your data. So that might be in the same data center. So it might be 3 different servers in the same data center. Or if you use availability zones, it will actually be spread over different data centers as well. And that way, even if one of our servers goes down, it will just immediately switch over a different server. You can just continue working. Same if the whole data center goes down and if availability zones enabled. If the data center goes down, we will just switch over to the next data center. You will have a minor hiccup and you can just continue working there as well. And finally, we integrate with other Azure services. So the 2 most important ones for Service Bus are Logic Apps and Functions. So Logic Apps is our no-code, low-code experience where you can basically just drag and drop your workflow. And we have connectors there for Service Bus. So you don't have to know how Service Bus works under the hood. You don't have to know about SK. You just drag a shape on there, you configure it, and it will just send, receive, etc. Similar for Functions. So Functions is our serverless compute platform. And with Functions, we have bindings as well that also take care of this. So you just add a binding there. And at that moment, you can send, receive, and work with messages with Service Bus as well. So very easy to get started, either with the low-code, no-code platform on Logic Apps, or with the code platform on serverless with Functions, or of course in any other of your own applications. So Service Bus is part of the Azure messaging platform. And there we go. And so the Azure messaging platform is basically the wider messaging team. So I'm the PM for Service Bus. We have a total of 3 different messaging services, though. So those are all the same team. And then also in our team is one adjacent service that we also talk to today. But first, so Service Bus. So Service Bus is our message queue broker and is used to connect apps on an enterprise messaging queuing and PubSub platform using open protocols, including JMS 2.0. So like I said, you have one or multiple producers, they send messages to Service Bus. You have one or multiple consumers, they pull messages out of Service Bus, either with queues or PubSub. So with PubSub, you push it in and you can have one or multiple subscriptions. And then each message gets either published to all subscriptions, or you can also use filtering on that. So the messages are routed to a specific subscription. So let's say that you have a web shop and you can deliver both in Europe and in US. You might have a subscription on there that says if the location is in the US, then go to my US warehouse. If the location is somewhere in Europe, then go to my European warehouse. And then the right systems will pick those up. And so on each subscription, once again, you can have one or multiple consumers. Each message in each subscription gets consumed by one consumer, but you can have multiple subscriptions, so you can basically distribute those messages around. Next up is Azure Event Grid. So Azure Event Grid is our elastic PubSub broker. And so Event Grid allows you to publish and subscribe MQTT messages and HTTP push and pull for delivery of discrete events. So with Service Bus, we're talking about messages. So message is basically, I want you to do something for me. So it has an intent behind it. I want you to create an order for me. I want you to update this invoice. I want you to give me back some data. So there's an intent. I might not know which system out there is going to do this for me, but I know there's some system out there that's going to do this for me. With events, it's a bit different. An event is more like a notification. So something happened and someone might be interested in this. However, it's not part of my business process, but I still want to notify other business process about this. So you can do that with both push and pull delivery. So we actually recently added pull delivery. So it used to be push, but now you can actually do push into Event Grid, push out to other applications, or those other applications can now pull them as well. Also, recently we added support for MQTT. So you can now basically use any MQTT broker, connect to Event Grid, and you can just start sending and receiving MQTT messages. So if you're in the IT space, this is a very good way to handle those MQTT messages, and it will just help you implement those IT scenarios. Then we have Azure Event Hubs. So Azure Event Hubs is our event stream engine. So it's a cloud scale, low latency streaming platform supporting Apache Kafka and MQP clients and services. So once again, this is about events. So it's more about things that happened, not so much the things that you want to get done. But in this case, it's about a stream of events. So Event Grid was about discrete events, so events that do on our own. Event Hubs is about a stream of events. For example, the temperature in your room. It might be things like logging data. It might be clicks on your website, but there's a stream of events coming in and you want to go over that stream and basically do aggregations on top of that, do analytics on top of that. And that's where Event Hubs comes in to get that ingestion engine there. So it's compliant with Apache Kafka. So if you have an Apache Kafka application, you can just change your connection string to Event Hubs. It will just work. We also support many of the Apache Kafka, how do you say, landscape. So things like Apache Kafka Connect and things like that. So you can very easily move your Apache Kafka application to Event Hubs, have it fully managed on a PaaS platform without having to host it for yourself. And finally, so like I said, we have 3 event or the 3 messaging brokers basically, but we also have Azure Stream Analytics in here. And Azure Stream Analytics is our event stream processor, and that's very tight integration with Azure Event Hubs. So that's also why this is part of our team, because we want to make sure that you get the best experience here. So Stream Analytics is our real-time stream processing and analytics engine, with rich development tools and a low-code, no-code editor experience. So basically what this means is you have that stream of events in the Event Hubs. You can now add Stream Analytics on top of this. So it will listen to the stream coming in, and then you can start doing analytics with this. So you can start doing things like aggregations, analytics. It comes with low-code, no-code editor experiences. So you can basically just drag and drop. It will get you the message format, etc. And it's a very easy way to process that stream of messages that's coming through. and then pushing them out, for example, to Power BI, to another Event Hubs instance, to Service Bus, or to many other services. So about 75% of the S500 customers actually use 2 or more of our messaging services. And why is this important? It's because I want you to understand that these are different scenarios that you will use this for. So messaging versus eventing, streaming versus discrete events is different scenarios. So look at your scenario and make sure you choose the right option. What we often see, and this is not something new, but we see these days, for example, with Kafka, we see this a lot, where people are like, I have a hammer, so everything is a nail. So they now start using one single service for all their different messaging needs. Where you really should not be doing this. You really should look at, okay, what do I need? Do I need enterprise messaging? Do I need that elastic scaling? Do I have a stream of events? And then choose the right service to basically build your product on. So we are very much about open protocols, open standards. So we have support, for example, for cloud events in Azure Event Grid. So cloud events allows you to do eventing cross-platform, cross-cloud. So of course, Microsoft is into this, but also Google Cloud, AWS, Oracle, a lot more that I don't remember right now. But basically, it allows you to have a single event description, and then you can just send this to over your different clouds, over your different systems, and they will just understand what's in here. They're also working on related things, like they're working on an X registry, for example, where you actually have a registry of your different messaging services. So cloud events is one of those really good opportunities for us to have open protocols, open standards that we can hook into. And so that's what we are doing with Event Grid. AMQP support, like I already said, Azure Service Bus supports AMQP, as does Event Hubs. So if you have an existing client that's using AMQP, you can just connect it to our services and it will just work. So MQTT support for IoT scenarios in Azure Event Grid, Kafka support for Azure Event Hubs, and finally JMS for Service Bus. Like I said, what we want to do is make sure that if you are coming to us from a different service, you can very easily hook in, but also that you are not locked in with us. We want to make sure that if you decide for whatever reason that you are going to a different provider, that you have the option to do this without being being locked in into our protocols. So that's why we make sure that we have all these open protocols, open support, and we also are active in developing these. For example, cloud events. My colleague Clemens Vasters, who's also in Germany, he's actually on the board of cloud events. He's helping actively to develop this specification. And so we don't just use this, but we also give back and make sure that what is being built there is the right thing for all our customers, whether they're on Azure or still living somewhere else. So that's Service Bus. So now let's have a quick look at our upcoming previews. Both of these previews will be going into private preview, probably like one of them next week. I think the other one probably next month or something like that. But both of these are basically also related to that performance, throughput, etc. So the first one I want to talk about is Durable Terminus. And so Durable Terminus, before I go into the feature itself, I first have to give some terminology here. So a terminus is basically the encapsulation of your endpoint state associated with your AMQP terminus. So an AMQP terminus is basically the source or target for your messages. So it's basically the endpoint on your service or on your client. And between those terminuses, you have a link. Now, what happens at the moment is when you are having a connection issue, that link breaks. So for example, you are running on containers because you want performance, so you are running on a lot of different containers, but one of your containers goes down and gets restarted. Or a function, same, like if your function restarts. Or it might be because your network breaks, because you are using distributed systems, you are running your community client somewhere else than your Azure loads, and there's network hubs in between those can break. Or maybe it's because we are doing upgrades, for example, like we upgrade your service, that will also break that link. And when that link breaks at the moment, you lose your message state. So that means that you lose your message logs and your session logs. So what happens in this case is that if you lose your message log, the message becomes available again on the queue and it gets picked up by the next consumer. Now that of course means that your other consumer might have started work on this, might actually still be running, but now you're doing that work a second time, which is not something that you want. So with Durable Terminus, basically what we allow you to do is recover a broken link. So your client can basically just reconnect saying, hey, I'm this client, I'm using this Durable Terminus. So it will introduce new log modes. So next to peak log and receive and delete, we have a durable log mode. Name might still change, but that's what we are calling it now. And when you use a durable log, basically we don't give back that mesh state, but we keep the mesh state until you come back to recover that broken link. So you will reconnect saying, I'm this process, here's my credential that I previously used. You will reconnect. And of course, if you use our SDK, this will always be handled for you. But if you reconnect, you'll get back your full mesh state. And that means you will keep your mesh logs and your session logs. And so especially like if you're running on containers and things like that, this will be very important because that's where we see a lot of these issues happening, where containers restart, etc. So if you come back again with the same process, we will just give you back your mesh state and you can continue processing the message. Now, the other preview we are working on is geodata replication. And this is something that has been asked by pretty much every enterprise customer I've been talking to. And so, of course, if you're doing high performance on Service Bus, that probably means this is also a mission critical system. So you will want to make sure that if something goes wrong, that you can immediately continue processing. And with the geodata replication, we are basically introducing a new GeoDR feature. So we already have GeoDR at the moment, but our current GeoDR only does metadata. So basically replicates your queues, your topics, things like that, but doesn't replicate your messages. So with the new GeoDR feature that we're working on, we will have full data replication across multiple regions. So this means that you can have one primary, one or multiple secondaries, and then if your secondary goes down, you can easily switch over to another region and continue your work there. It has full data replication, so your full mesh state will be replicated. Now, there's one thing about this. When I say that we are going to replicate your full mesh state, we are going to give you two different synchronization modes. And we do that because we are not allowed to break the laws of physics. So unfortunately, there's this little thing called the speed of light that we cannot break. And so basically, when you have a different data center in a different region, that means if we have to replicate the data, we actually have to send the data there, wait for it to be committed, and wait for the response back. Now, unfortunately, we cannot break this. So what we are going to do is introduce two different replication modes, synchronous and asynchronous replication. So synchronous replication will basically be your RPO 0. If you cannot have any data loss, what you will do with synchronous replication is your producer is going to send something to the primary region. We are going to commit it on the primary region. We are going to replicate this to the secondary region or multiple secondaries if needed. We are going to wait for quorum to come back. And once you have a quorum coming back, then we are going to acknowledge this back to the producer. And they know, okay, this message is now at least in 2 different regions. So if something goes wrong, I can fail over and it will still be there. Now, this has an RPO of 0, so no message loss. But of course, this does mean that we have to wait on the speed of light to actually go over to that different region, etc. Now, one of our customers is going to go from do GeoDR. So we are talking to them now, and they want to do GeoDR between Australia, Japan, and Europe. Now, as you can imagine, if we have to wait for that, that basically means that we have about a second per message extra latency. So that's not something they want. So what they want is basically the asynchronous replication. So what we are going to do there is your producer is going to send it to the primary, we're going to commit it to primary, and then we're going to acknowledge back to your producer. So that moment you now know, okay, it's in one region, and then now we are going to asynchronously replicate this to the other regions. What you can do here is you can set your RPO. So you can, for example, say my RPO is 10 minutes or my RPO is 1 hour. What we are going to do is we are going to keep track of that replication lag. So we are going to see how much lag is there between your primary and your secondaries. If we see that replication lag hitting that RPO that you set, so for example, that 10 minutes, if it hits that replication lag, if it hits that 10 minutes, we are then going to throttle your producers. Because once you start sending in more data, you lose more data than you're allowed to. And this way, you still have that latency that you currently have because you only send it to the primary and get your response right back. But you also have that knowledge that, okay, I might lose 10 minutes or 1 hour or whatever you set of data, but everything beyond that will still be there. Now, when you, of course, at some point you want to do a failover. So you want to move over from your primary to your secondary. One difference between what we currently have and what we are now building, at the current GeoDR feature, basically you set up 2 different namespaces. You create a link between those. And then when you fail over, you need to break the link, create a new namespace, link that again. So it's quite involved now. What we are going to do with this new feature is actually just have a primary with multiple secondaries. So not different namespaces, but just have different secondaries. And so when you switch over, fail over, you're going to say, I want to fail over to this secondary. You're going to fail it over, but at that point, you can also just fail back again to that old primary. How you're going to do the failover is with telemetry. So it will be a failover. So you will be in control, but we are going to give you the telemetry so you can automate this. And what that means is you are going to get telemetry about the healthiness of your secondaries and your primary. You're going to get telemetry about your replication lag. And with those different with that telemetry, and of course during the previews, you are going to see if there's more telemetry needed. But with the telemetry, basically what you can say is, okay, if I see that my healthiness of my primary is not okay, I want to switch over to a secondary. And you can now do this, for example, with Azure Monitor by looking at those metrics, looking at the telemetry. You can automate this with Azure Monitor or maybe something else you want to use. But so you can basically automate your manual failover. The reason why we don't do an automated failover for you is because often when you want to do a failover, you don't want to just fail over Service Bus. You might want to fail over Service Bus with its according functions. Or maybe Service Bus is fine, but it's a different component that needs to fail over, and you want to fail over Service Bus with that. So we can detect maybe 10, maybe 20% of cases where we should fail over, which basically Service Bus is down. But 80% or so is actually where we cannot detect if you want to fail over. So that's why we give you this manual failover option, but we give you the telemetry to automate this, so you can then fail over Service Bus, but also include other services if needed. And finally, we are going to release this for both for Event Hubs and for Service Bus. So actually, Service Bus and Event Hubs have quite a lot similar architecture. So I think we share about 70 or 80% of our architecture is actually shared. So a lot of the platform features that we built, like GeoDR, we can actually share among these different services. Then, of course, there are other things that are specific for Service Bus or specific for Event Hubs. Like if we are talking about queues, we are always talking about Service Bus. So those are implemented in their own architecture. But the underlying platform is shared. So that's why you actually will see both of these coming very soon. So that's what's coming soon. And like I said, they're going to private preview like very shortly. Public preview, hopefully maybe Ignite if all goes well in the private preview. No promises, of course, because it depends what we will find. But maybe we can have public preview around Ignite or maybe end of the year or something like that. And then you can all start trying this. Now, what have we recently released? So recently released, what we did is, for example, passwordless authentication for JMS. And like I said, Service Bus fully supports JMS 2.0. We also support JMS 1.1, but that's only limited. But JMS 2.0, we have, I think, about 95% of compatibility with. And so what we see is a lot of our high-performance customers actually come from brokers such as IBM MQ or our typical AMS, and they're now moving to Service Bus. So they still need that performance they had with those on-premise systems, but with a SaaS application. Now we are working on that, but one of the parts of that is also once they move over, they have to now actually authenticate. So when they switch their JMS client over to Service Bus, what they can now do is basically use AAD-backed authentication. Up until now, we released this about a month ago, I think, maybe 2 months now. But up until that point, you had to use SES tokens. And I don't like SES tokens because you have to rotate them, you have to keep track of them, who has which ones. But now with AD-backed authentication, you can basically just create an identity in your Service Bus or in your AD, and give that access to your Service Bus instance. Which now means you can use all the nice things like having groups in there. You can keep track of who has access to what very easily. You can remove access very easily. You don't have tokens that you have to rotate. So this is much better. And we have support for both managed identities and service principals. So I have this code snippet over here. I will be sending out my slides later on. It's also in documentation, by the way. But so basically, it's very easy. Just create a token credential and then you connect with that. So it's very easy to set up, like it's 2-3 lines of code that you need, and then you can authenticate using your AD-backed authentication. Now, like I said, we have been working a lot with customers over the last year and a half to have better performance. And so some of the performance features that are currently in public preview are, so basically we have 2 features that are public preview. And one of them is consistent low latency on your entities. So this is a feature where we basically moved our storage engine. So for those that don't know, Service Bus is running on Service Fabric. And we used to have Azure Storage as our backend storage. So what would happen whenever we had to write something to storage, was basically every time you send in a message, every time you do an update, we had to go to Azure Storage and update our blobs there. Now, what that meant is that if we had any network issues, and network issues happen a lot more than you think, if you're talking about milliseconds of latency, all of a sudden, whenever we have one small hiccup, it doubles our latency. So we immediately saw that. So whenever we had an issue on our network, but also when Azure Storage had an issue, we had troubles with our performance. So we have now moved to a multi-tiered storage provider. So there's actually a couple of microservices that we built. But basically what it does, it goes to our local storage first, so the Service Fabric storage first, and then we offload an Azure Storage as needed. But because we are going to our local storage first, the first thing we have is more consistent latency, because we don't have any issues anymore with the network, with Azure Storage, etc. Because we always go to our local storage. So it's much more consistent latency, but also it's lower latency. We used to do about 50-ish milliseconds end-to-end latency. We are now down to about 35 milliseconds of end-to-end latency. And of course, we are still working, and that's actually our P99, so most of our messages will actually have lower than that even. Of course, we are trying to bring that down more, but this is one very big step in the process. So it vastly improves reliability as well, because we are now first going to our own internal storage, our own local storage. That means if Azure Storage is having issues, we don't get impacted by that anymore. And when I say issues, like when we are talking about issues, often we will think about outages of minutes to hours. For us, an issue is basically when our backend systems go down for seconds, because that means that your messages are not being processed for those couple of seconds. And that means that we get a lot of support requests. So by going to this local storage, we now actually have much more reliability and performance. So this is actually something that will be coming to all the premium SKU users next year. So this why next year? So we actually can already get this. So I'll talk about that in a second. But it will come to everyone next year because we are in a process of a big infrastructure migration. So we are moving our infrastructure from cloud services to virtual machine scale sets. Now, what we get with virtual machine scale sets is we get a lot of nice goodies, like we can get availability shows everywhere, but also we can run this new storage provider on that. Now, because everyone will get this in the end, we did not want to put this behind a feature flag or behind ARM key or something like that. So what we did instead is we combined it with a different feature, which is partition namespaces for premium. So when you create a partition namespace, you also get consistent low latency entities. So what are partition namespaces? A partition namespace is basically where you enable partitioning on that namespace. And so it allows for high scalability by allowing multiple partitions in premium namespace. So when you create a new namespace, currently it's, I think, in 2 different regions. We are rolling out in more regions in the coming couple of weeks. Like I said, it's still in public preview. But when you go to create a namespace, you will get this drop down with your number of partitions. So you can set the number of partitions from 1 to 4 at the moment. We'll probably give you more partitions later on. But during public preview, you can get 4 partitions. And each partition then gets the number of mesh units that you provide. So let's say you do 4 partitions and 1 mesh unit, you can then get 4 mesh units. Now, what this means is you can now scale from 4 to 64 mesh units. And like I said, for those customers that are looking for like 100 megabytes per second, this is what we needed. Up until now, we could only give you 16 mesh units, and then we were done because our clusters could not scale further than that. But now, because we are using partitioning, basically we can now use different clusters, which means that we can scale you indefinitely. If you want to have 128 partitions, please let me know because I will be very happy because that will be a lot of usage. But we can do it now because it's literally like we don't have any physical limits anymore. So we are just limited by the amount of service that we have. So if you want, you can basically just scale up indefinitely. I would say use this only when you have a single workload that needs high throughput. If you have multiple workloads that all need some throughput, use them in different namespaces. Because we are now improving this specific part of our performance. However, there's still other parts where you might still run into performance issues or other limitations. For example, the amount of connections. So you can only have 5,000 connections on a single namespace. So if you have different workloads that all need to performance, put them on different namespaces. If you have one very big workload, so for example, the crypto broker I was talking about earlier, they have one very big workload that they need to do this on. So for them, this basically helps them a lot because they can now scale much higher than they could do before. So it's really for high throughput scenarios, and where absolute order and message distribution is less important. Because you are using different partitions, in the backend, basically we are creating different namespaces. So let's say you have 4 partitions, that basically means that you have 4 namespaces or 4 clusters in the backend. So what we will do is basically distribute your messages around those 4 different clusters. Now you can actually get still get relative order. So messages are in the same partition will have the still have the order kept. You can also still enforce absolute order. So you can use a partition key to make sure everything gets sent to the same partition. And you can use sessions if you want to have everything handled by the same consumer. So you can still have that order. However, there's a performance impact with that. And I will talk about that more in a minute. But once you start in using things like partition keys or sessions, it means that we now have to do checks on this, like, hey, which partition does it have to go to, which consumer can pick this up. So it's extra CPU. So that means that you lose some of the performance, and then you would have to get more message units to get to the same throughput. Okay, so we now know what is coming, what are we building, what are we have released. So now let's actually go into the performance optimization itself. So how can we now, knowing what is out there, what features we can use, how can we now use this to actually optimize our performance? And so performance optimization is not just when you want to have 100 megabytes per second. It's also when you have smaller workloads, but you want to limit the number of message units that you need to use. So for example, if you can work with 1 message unit instead of 2 message units, that basically means that you pay half the price. And of course, we want you to use our service, but we want you to use it in a logical way. So we want to make sure that you get the tools that you can actually get the throughput that you need. And why am I telling this? It's because I was talking to a customer, I think about 2 months ago, that came to us. Service Bus is very bad performing. We cannot get any throughput on this. And basically what they had 16 message units, so basically the maximum amount on one single namespace. 16 message units, and they were doing about 2,000 messages per second. So we were looking at that and we're like, something is wrong here. We definitely know that you should be able to, with 60 message units, you should at least be able to do like 20, 30,000 messages per second. So we started looking at what they were doing, and there was a lot of things they were doing wrong. So for example, they were not reusing their clients. They were not caching things. They were not using prefetching. So there were a lot of different performance optimization that they could do. And basically what I want to do now is go over those different things that we have seen with different customers and talk about, okay, how can you get the best performance out of Service Bus? So first I want to talk about the SKU. So in Service Bus, we have 3 different SKUs. We have basic, standard, and premium. We don't talk about basic. You should not be using basic. Please get away from it. So standard is our SKU where we see most of our customers. So standard SKU is basically our serverless SKU. You pay as you go. You pay for per million messages. And it's mostly used either for development and test scenarios. So where you do your development against this, so you can see like, okay, our message is being routed correctly, etc. Or your low throughput scenarios. And so basically what you get with Service Bus Standard is you get 1,000 credits. And so whatever you do on your messages will use up some credits. So send, receive, defer, abandon, all are 1 credit. And then you do things like update the queue, for example, that's 5 credits. So depending on how many messages you have come through, you can start hitting those credits. So that's why it's for low throughput scenarios, because you just get 1,000 credits and you cannot get any more. But that still means that you can do like, if you have like a small workload that doesn't need like all those premium capabilities, standard is fine for you. One thing to think about though is it's on shared resources. So you are getting resources that are shared with other customers. Like I said, it's a serverless model. So we just put multiple customers on the same resources, which means that you can run into noisy neighbors. So let's say that a big customer, like let's say Facebook comes on your namespace on your cluster, and Facebook also starts using this for all of their different notifications. I would say for Twitter, but Twitter doesn't do anything anymore. So let's go with Facebook instead. But yeah, but so if you have a customer that's next to you that has all of a sudden a very big burst, that means that the resources are getting used up, and that might mean that you don't have resources to do your messaging. So at that moment, you can be throttled. So this is something to think about. So throttling can occur because you're running into your credits, but throttling can also occur because another another customer is using up the CPU, memory, etc. Now this is fine for a lot of scenarios. Often you don't care it's in like in 20 milliseconds or in 50 milliseconds or 100 milliseconds. Often you don't really care. But if you do care, and that's often with these high throughput scenarios, if you do care, then you will probably go to premium. So premium is really for our production scenarios, like most production scenarios. So premium actually runs on dedicated resources. So you get your own CPU, memory, etc., dedicated to you. So that's basically that mesh unit that we're talking about. It's a certain amount of CPU, a certain amount of memory that's specifically for you. And you can use that however you want. So if you optimize your scenario right, you can get more throughput on that same kind of resources. So it gives you predictable latency, predictable throughput, and you know that, okay, once I get messages on this, I can just do a load test. And what I get out of the load test, that will be my throughput. I can optimize, of course, but I can be sure, like, okay, this is my throughput until I start changing things. Now, like I just discussed, we also have partitioning there, so you can also scale much further than you can do on standard. So like I said, on a single partition, you can do 1 to 60 mesh units. Once you start introducing multiple partitions, then each of those, like 4 partitions, you can get 4 to 64 mesh units. So this allows you to scale much further than you can do on standard. And something that still a lot of customers don't know is that you can actually auto-scale this. So we have support for auto-scaling, which can be either on time-based. So for example, if you know that every morning between 8 and 10, I get a lot of messages in, you can automatically scale up. For example, at 7:30, I will scale up to 60 message units and then scale down again at 10:15, for example. But you can also scale on your resources. So you can actually scale on the CPU used. So if, for example, if your CPU usage is over 70%, we would recommend, okay, scale up and then wait for it to go down again and then scale down again. And that way you can make sure that you can still handle any spikes, but are not paying more than is needed. So this is actually something that one of our largest customers implemented last couple of months. And so they literally cut their bill down about 50%, just because they were running everything on 60 mesh units. And then they found out, hey, we can auto-scale. So now they basically have everything on, I think they have standard for 4 mesh units. And then they just scale up as needed and scale down again to 4 mesh units as needed. So this is something that's very important to know because it allows you to get a throughput while still managing your cost. Next is namespace sharding. And so we will quickly touch on this. But so if you're talking about namespace sharding, basically it means that you will create either one very big namespace or multiple smaller namespaces. So with partitioning, you can actually create that one big namespace that allows you to go beyond 16 mesh units. And this is really for those really heavy single workloads. So if you have a single workload that needs 50 megabytes, 100 megabytes per second, definitely go for partitioning. Calculate how much partition you need with how many mesh units, and then basically allow for that to go on that single namespace with multiple partitions. However, like I said, not all the resources scale linearly. So for example, you will run into limitations on your number of connections there, but also on your entity size, but also just resources themselves. Like having two different clusters doesn't mean that you automatically have 2 times the resources, 2 times CPU, etc., because there's always some overhead of different things that are running on there. So it will scale not like times 2, but maybe like times 1.8. I don't have the exact numbers, but like that, the thinking about that kind of ballpark, times 1.8 to 1.9. So it might be better to actually just have a separate namespace for the different workloads. And that's where sharding comes in. So with sharding, basically you will run your workloads on multiple namespaces. So if you have any workloads that don't need more than 16 mesh units, they probably should be on their own namespace. Of course, if you have a lot of small workloads, you can run those on one namespace. We do recommend if you have like one bigger workload that's not quite 6 mesh units, but does go beyond like what you would need to go beyond 1 mesh unit, probably have it on its own namespace and then just auto scale as needed. Another thing that's nice about sharding is you can actually run different shards in different regions. And this also means that if you have workloads in different parts of the world, you can keep your message broker with your workload. And this also comes from that same customer I was talking about earlier that's doing like the GODR between Australia, Japan, and Europe. So they were actually running one single namespace within Australia and have everything connected to that. And of course, they ran into the same issues where they run into latency. So we actually were looking with them, and so basically they now split up their workloads into 3 different parts, and just use a namespace that's closer to their workload. So if namespace in Japan, namespace in Europe, namespace in Australia, and that also really helped their throughput and the performance, because now they don't have to travel half the world across the world, but they can just go to a very close node and actually just consume and produce on there. So something else that a lot of our customers don't realize is that if you start using features, that can impact your performance as well. Like I said, with Service Bus Premium, you get a certain amount of CPU and a certain amount of memory. However, if we have to do some things that will cut into that performance, because we need your CPU and memory for that. So for example, if you enable sessions, and so with sessions, basically what you do is make sure that messages that have the same session ID are processed by the same consumer. You can have multiple sessions next to each other. So for example, think about orders. I might have an order created, order updated, order delivered, order invoiced. And you want to handle those 4 different messages in order. But I might have 10,000 different orders, and I don't want to order 10,000 to wait for order 1 to finish. So by using the session ID with that order number, I can now make sure that those messages for order 1 are processed sequentially, while all the other orders are processed next to each other. However, to recognize your session, what we have to do is basically we look up in our backend, we look up, does the session ID already exist? If yes, if you're using partitioning, in which the partition is this, which client is connected to this. So we have to do some lookups, etc., to make sure that message gets placed in the right position of the queue. Now, of course, those lookups take some CPU and some memory, so that's a slight decrease of your performance. Similar to when you want to fan out multiple subscriptions. So if you have a topic with multiple subscriptions, you also have to start looking into, okay, which subscription should receive this specific message. This is especially true when you start using complex filters. So I've seen some really complex filters. I think the biggest filter I ever saw was about 50 lines of and or statements, etc. Now you can imagine if we have to actually do this against every message that comes in, we have to do that query on that. It takes some time to do that. So once again, that also adds some latency. Also schedule messages, because when a schedule message comes in, we actually will put it in the backlog, and then we have a background process that has to pick those up. So once again, that has some of those resources. Also deferred messages, because we are now putting those deferred messages in. So we now need to keep track of, okay, which messages are deferred. And once you start retrieving them, we have to pick the right message from there. Transactions also has a big impact, because once you are working with transactions, you actually have to keep those both of the messages. You have to keep the commitment around it, etc. Another one is deduplication. So deduplication, we actually have to go and check, did we receive this message ID before? So we actually have to do a lookup in our database and see, okay, did we receive the message before? And we have to do that for every message. And finally, forward to. Forward to also, we have to once again have a look at, okay, where does this message come in? Which message queue has this to be forwarded to? Do the forwarding. And so all these things they are amazing features, by the way. Like, I'm not saying don't use them, but I do say think about which features you are using. Because a lot of times we just see customers just enable everything they can enable and just randomly starting to do things where they don't quite understand the impact. And this is fine. If you are doing like 500 messages per second, you will never notice this. However, if you are doing like 10,000, 20,000, 50,000 messages per second, each of these small small pieces that have some impact start adding up more and more. So if you are doing like the customer I was talking about, 100 megabytes per second, you probably want to use as limited features as possible. Of course, if you need certain features, definitely do use them, but think about what impact does this have if I start using this. So some considerations I want to give you. First of all, think about which protocol you are using. So the protocol that you're using has a big impact also on performance. So basically at the moment we support 3 different protocols. So we support AMQP, of course, we support HTTP, and we support SBMP. So SBMP is our original protocol that we built for Service Bus. So it's the Service Bus meshing protocol. If you are still on that, please get off with it if you can. We're actually going to announce retirement of our old SDKs in a couple of months, which will also mean that the SBMP protocol will also be deprecated. It means that you will have 3 years to move off. So we are not going to just say, hey, you're done now. But if you are still using SBMP and you cannot move, please let us know why, because then we might be able to help you. We already have some limitations that are in MQP that will be for customers that cannot move because of that. But we want to make sure that everything you can do with SBMP, you can also do with MQP. So think about that. Now, that said, we advise you to be on the MQP protocol because the MQP protocol is really optimized for queues. It's literally the advanced mesh queuing protocol. So this protocol is once again open standard, and it works really nicely with queues. It knows about things like sessions, about transactions, about how to about asynchronous handling. And you can use HTTP as well, so you can use this as a REST service as well. However, because REST was not built for queuing, it has some added latency, etc. So if you want to have the optimal performance, please use MQP. Also think about which SDK you are using. So at the moment, we also have 3 SDKs. So we have the Track 0 SDK, Track 1 SDK, Track 2 SDK. So Track 2 SDK is azure.messaging.servicebus. If you are on one of the older SDKs, once again, we are going to announce retirement for that soon. So if you're on one of the older SDKs, please get to the latest SDK. Or if you run into issues with that, if you cannot move over for any reason, please let us know. But also definitely be on the latest SDK, but also the latest version of that SDK. We do a lot of different improvements also in the SDKs. And often when customers come to us like, hey, something is not working, or hey, I'm running into this issue, or I'm having these performance issues. The first thing we always tell them is please upgrade to the latest version of the SDK. And that fixes the problems in about 70%, I would say. Just because they might still be running on a SDK that was released 6 years ago. We have done so much work on this in the meantime, but they never upgraded the SDKs. So now once they upgrade, they now see, oh, now I actually get everything that I was expecting there. So please be on the latest SDK and the latest version as well. And also make sure that you keep an eye on this when new versions come out, that you also make sure that you implement this in your projects. I know I was consulted myself. I know we cannot just, hey, today something came out, let's implement this. But make sure that you get some time scheduled in your backlog, like, hey, we have to go over SDKs, we have to upgrade, etc. Also, the receive mode. Like I said, at the moment, we have receive and delete mode, and we have peak lock mode. Soon we also have a durable lock mode. If you want to have optimal performance, the best way to go is receive and delete. Because when you receive and delete, you just get the message and you're in control of it. It's gone from the service bus queue. So that means we no longer have to keep track of the message, which means that we can spend the resource that we would use for that instead on performance. Now, of course, there's a downside of this. When you have receive and delete, once it's removed from the queue, you are in control. If anything goes wrong, you are in control handling it. But for a lot of our customers that are doing like very high throughputs, they are like, well, if we miss like 10 messages out of this 1 million, that's okay. Like with that cryptocurrency we broke, for example, a lot of their messages are basically just stock tickers. If they miss one of those intermediate stock tickers, it will be updated 1 second anyway. So of course they want it, but if they miss a couple of those, that's okay. So think about, can you handle that loss? If so, receive and delete might be a good option for you. Also think about our quotas and limits. Like I said, for example, we have 5,000 maximum connections. Make sure that you don't use those connections up, because once you do, you start getting throttled. Also look into the maximum entity size. So on Service Bus Premium, you can have up to 80 gigabytes entity size. If you hit that 80 gigabytes, everything will stop. So that means that all your incoming messages will be throttled and nothing is moving anymore. The reason why we most often see that quota being hit is because people don't clean up the delete queue. So we literally have customers coming in that have millions of messages in the delete queue, like from years ago. And when we ask them, like, are you ever going to do anything with those messages? They don't. So make sure that you clean up your delete queue and make sure that you don't hit that 80 gigabytes. Now we are actually looking into some options here as well, because we have some customers. We have one customer that does automotive data. So they get all the telemetry from automotive, like about the engines, GPS, etc. When they have an issue in their backend, basically they hit that 80 gigabyte after 30 minutes. So, and you know, like whenever you hit a proper incident in the backend, it will probably take more than 30 minutes. So that means they start to lose messages in there because they're being throttled. So we are looking into options there. One of the options we are looking into is basically just increasing that size. But even that is just a postponing of things because we cannot increase that indefinitely. So we're also looking into maybe archiving or offloading data from your data queue or even from your normal queue if you want, offloading that to storage with an option to play them back once your backend is up again. So those are some of the things that we are thinking of there. And finally, look into batching store access. Probably you don't need to look into this. If you have not changed it, it will be optimum. But so the batching store access basically means that in our backend, in our Service Bus cluster, we have some batching that's going on. So we basically look up the next 20 messages or so when you are receiving. You can disable this. Please don't. There's no good reason to disable this. We have the option in there, but there's like, if you don't know why you need this, you don't need this. Let's put it that way. If you need this, then you will have talked to us and we have told you to enable this. So if you have this set to false, then please remove the line and put it back to true again. So something else that we often see happening, and this is one of the ones I also will be talking about with the one that had 2 megabytes per second on 60 mesh units. And this is basically where they went wrong most. If you're using factories or clients, please create them as singletons. So please reuse your client whenever you're using that client. So don't create a client, send your message, destroy the client, create a new client, send a message, etc. Now just reuse your clients. We have built-in support, especially if you're using our SDK. We have built-in support that handles all the connections, etc. for you. So please just instantiate once and then share that same client all over. Please don't dispose of the client or close it. If you close the client, you also close your link. Now, like I said, when your link is closed, we have to re-establish the link, which takes like a couple of 100 milliseconds. If you dispose the client, we completely throw away that whole connection, which means you're now looking at about 1 second to reconnect. So if you have a client that you continuously recreate, that means that you constantly dispose the client. And this is why that customer that I was talking about only got to 2 megabytes per second. Once they switched to reusing their clients, they could then all of a sudden do 20 megabytes per second, just by changing that one piece of code. So this is basically the one that I will say, if you're not doing this, definitely do this, because this will give you the biggest performance impact of everything I showed you today. Now, also concurrency is something that you have to think about. So operations take time. So if you are sending a message and you're just waiting for the message to be sent and then send your next message, that will take some time because you have to send it, we have to commit it, we have to give you back the response, and then we'll go to the next one. So instead, use async tasks, gather up those tasks, and then do all the tasks at once. So as you can see here, you can just use an await task when all. So just gather up your tasks of all the messages you want to send them all at once with when all, and then when all of them come back again, then you can continue. So this is also very small change that you probably need to make, but that does help you a lot with your performance. Another thing to think about is prefetching. Now, this is not something I would recommend to everyone because it depends on your scenario. But basically, if you enable prefetching, what you will do is you set the amount of messages that you want to prefetch. So what your client will do is when it asks for a message, it will say, give me the next message, but also give me the next X messages. So let's say that you set a prefetch count of about 20 messages. It will actually get you 20 messages. Those messages are now all locked to you, so you actually have to process them. But then you now have 20 messages waiting for you, and it will actually backfill this as well. So it will make sure that you constantly have 20 messages going there. So this reduces the throughput by reducing the amount of round trips, because you now don't have to wait for getting message, wait for the service to actually give you the message. We'll just have them ready. So basically, load those additional messages when you receive, and just make sure that you have those messages lined up. Like I said, they are locked to that specific client. So if you prefetch 20 messages, those 20 messages are locked by your client. So make sure you can handle them within the lock time, because we have a lock time of 5 minutes at the moment. With durable lock, that will actually disappear. But for now, if you have a receive peak lock mode, you have 5 minutes to complete that maximum. Or you have to renew your lock. But basically what we would say is, don't prefetch more than you can handle in probably 1 minute or so. If you can handle those messages in 1 minute, that's pretty much the amount that you should prefetch, because that means that you don't have to change anything on your log times, etc. It means that you will have nice throughput. Also, make sure that you have enough consumers available for the different messages. When we don't recommend this is if you need either high reliability, because there are some things once you start getting those messages, because they are locked, if something fails, the counter gets increased. After 10 times it goes to the dead letter queue. So that is something that you might run into. And also don't do this if your processing takes a lot of time or work, because like I said, you actually have to lock on the messages, so they are now locked to that client, so another client cannot pick them up. So only do this if you have like very fast work, where you can basically just say, okay, just keep it coming, and I can just very quickly go through them. So the before last one, batching. So make sure that you batch your messages. So both on send and receive will allow you to do batching, and that also quite improves the performance. I will give you some details on that in a couple of minutes when I go to my demo. But batching is also next to the reusing of your clients. This is probably the second thing you can do to increase your throughput. So especially when you're sending, like, say, batch up those messages, you can set the batch size. The SK will automatically handle this for you from then. Make sure you choose the right batch size. So once again, it has to make sense. If you had to wait 10 minutes for 20 messages to arrive, then probably 20 is not the right batch size for you. But look at if you're producing a lot of messages, just at the batch size, maybe 20, maybe 50, whatever. There's some figure out to do what you can do here. Make sure that you set the right batch size, and it will increase your performance drastically. And finally, make sure you calculate your throughput. So we have actually a benchmark tool for the Service Bus Premium. It's up on GitHub. It's completely open source. I will show it in just a second. But with the benchmark tool, you can basically do it, just point it to your Service Bus instance and see how much throughput you can get. Of course, make sure you use production-like workloads if you're doing a benchmark like this. Like I said, tools open source, so if there's any specific settings that you need, you can add those to your client as well in the benchmark tool. Make sure you apply those best practices that I just talked about. A lot of them are actually already built into the tool itself. You can actually look there how we do this, but also make sure that you have your configuration right, etc. Here's the link. Like I said, I will send this presentation later after my session. It will be on my Twitter, but if you want to take a screenshot, you can do that now. And next up, I'm actually going to do a quick demo. So here we go. And in this demo, I want to show you the benchmark tool. So I already have the benchmark tool over here. Where's my mouse there? So I have the benchmark tool over here. As you will see, when you download this page, what you will get. And so there's a lot of things in it, but most importantly, there's the sender task and the receiver task. And so the sender task is basically, when you start the tool, you will specify I want to have X amount of senders, X amount of receivers. And for each sender, it will spin up one of these sender tasks. I'm not going to go in detail about this code. Like if you want to look into this, it's open source, so you can just look at it. Basically, what it will do is start sending messages. Now, there's a lot of things that, like I said, if you want to know about how you can maximize performance, I would definitely have a look at this code, because there's a lot of smart things in here. It was created by Clemens Fasters in combination with my engineering team. So this is really built by the people that built the service. Like, this is how you get the best performance. So go through this. For the receiver, the same. But basically what I did, I won't run the tool now because it takes about 5 minutes per run. I did, I think 5 or 6 runs beforehand. I don't think we want to be here for another half an hour for me to do all those runs. Basically what I did is just have different scenarios. And so basically I start with one sender, one receiver, one concurrency to one, no batching, and then I up those numbers as we go along. Now basically what you just will do is this line. So this is an important line. Let's get rid of this. So this line, you just call your throughput DLL, you give your connection string, and then you pass in those parameters. There's a README on what each of the parameter does, but here I just say I want to have X amount of receivers, X amount of senders, concurrency, and batching. And so if I go back to my presentation, like I said, I already ran this before. And so basically when I run this with a single client, so one receiver, one sender, like concurrency to one, I get about 40, 50 messages per second, so both send and receive. Not too bad, but like if I have multiple clients, this might be okay. But this is my throughput on a single client. Now, if I start using multiple clients, and you can actually use multiple clients on a single server, of course, like a single process can spin up multiple clients as well. So that's basically what we do in that demo tool, the benchmark tool, is we just spin up multiple clients and start using those. So with 50 senders and 100 receivers, no additional concurrency, I already went up to about 2,800-ish messages per second. So from 40 to 50 to 2,800 is quite an improvement, I would say. And that's just by spinning up multiple clients. Now let's have a look what concurrency does. So I'm going back to a single sender, a single receiver, but doing 100 parallel in-process flights, sends and receives. So basically this is you're queuing up those tasks and then just waiting for the task to happen instead of just running one task. So having 100 tasks concurrently brings it up to about 2,300 for sending, 4,500 for receiving. So actually the other way around. So 2,500 for receiving, 4,500 for sending. So once again, just by adding concurrency in there, and this like it's a couple of lines of code, you immediately have about 100 times the performance. And now multiple clients that are all running concurrently. Once again, 50 senders, 100 receivers with 100 concurrent threads. I go about to 6,500-ish send and receive, 7,000 per second. And by the way, this is all on a single partitioned, single messaging unit namespace. So as you can see, even before I go into like increasing my namespace number of messaging units, I can already enhance my performance quite a bit just by working with my client. And then the final one, adding batching. So the same one that we did before, now adding batching. So I'm doing batching on my senders. So doing 200, a batch of 200 messages, prefetching 100 messages per time. And the receiver, as you can see, did not take this at the best time. I do this quite early. But let's have a look at the sends. The sends are now up to 30,000 messages per second. So basically we went from 7,000 messages to 30,000 messages per second just by adding batching. And so as you can see, there's a lot that you can do here. I will share all the documentation around this in my final slide. But as you can see, just by tuning your clients a bit, and these are often like 1 or 2 lines of code that you need to change, you can have much higher throughput on the same namespaces. So with that, we're almost done. So I do have a couple of takeaways. So first of all, performance is key. Like really, once you start designing your solution, look into the performance. Because like I said, you might not have that 100 megabyte per second scenario. You might just say, I do 500 messages per second, I'm fine. Still, you want to make sure that you get the best performance and also that you can grow within that single mesh unit or whatever many mesh units you have. You want to make sure that you can get the best throughput, the best performance out of that with those resources. So really design and implement with performance in mind. I will give links to everything I discussed today. We have quite a big write-up on a lot of this as well. Of course, have a look at your code, have a look at your solution, have a look at your configuration. And finally, please provide your feedback. If you find anything where you're like, hey, this is not working as I'm expecting, that might be something specific to performance, but also feedback in general about Service Bus. We want your feedback because this helps us building the best product that we can. So with that, I'd like to say thank you. Of course, my contact details, Twitter, my email, LinkedIn. 2 links I want to call out. So the first one, aka MS Azure Service Bus feedback. This is where you can provide your feedback. It's Azure IDs. This one is specifically for Service Bus, but we have on the same page, you will all find all the other services. You can submit your own IDs there, but you can also upvote IDs from others. And I looked at this every week, and I make sure that once things are upvoted, I look into, is this viable, get into the backlog, discuss it, and hopefully we can then at some point actually plan it to be built in. The other one is SB Performance. So that's basically our performance guidelines. A lot of what I talked about today you'll find there. So if you want to have that quick reference to how you can set things up, please have a look at that. And finally, behind the QR code, there's my GitHub. It's github.com/Eldert Grootenboer. but it has the resources for all my different sessions. So it has my slide deck there. I will once again send it out on Twitter if you want to grab it from there. But if you want to have a look at my slides and my code, everything, it's over there. You are free to use it in any way that you want. I hope you all enjoyed this session. And if there's any questions, please let me know.
That was awesome. Awesome. Really great.
Thank you.
Questions? Yeah, I have some, but I will just keep mine as long others asking questions.
Yeah, regarding the pricing, I mean, there's standard and premium, but how is the pricing, Eldert? It's per how deployment time, or it's also per operations?
So for standard, it's for operations. So standard, you pay per million operations. It's like a couple of cents per million operations. For this premium, you pay for your message units. So each message unit, you pay, I think it's $600 per message unit, and then you pay per hour. So you spin it up, and then we will charge you per hour. So of course, your production environments will probably be online all the time. So you just pay the $600 per month for that. But for example, if you are on a test environment or a development environment and you don't need it all the time, we do recommend to have some scripts like, for example, with Terraform, but actually create those resources on demand. So for example, dev environments, you probably need from 9 to 5 during the weekdays. So you can create them before you come into the office, have them ready when you're there, and then break them down again after you leave the office. And also like over the weekend, you can turn them off, like you can destroy them. It's quite fast to create a namespace these days. It used to be a lot much longer, but now you get a namespace within seconds to minutes maximum. So it's very easy to just spin it up. You will just be charged per hour. So and if you don't have them running, then you don't get charged for them. So that's actually something that we often advise for like dev and test environments to do that way, because it will just save you a lot of money.
Okay, thank you.
So, Eldert, you said in regard to keeping performance, you should consider MQP for having a good performance. I thought a little bit that MQTT would be a little bit more slick and therefore a little bit more performant, but I didn't get the point.
So MQTT we do not support on Service Bus. We do support it on Event Grid.
Yeah.
MQTT is we really added to Event Grid because we think it makes more sense on Event Grid because it's really about small events based that are happening, like IT messages, small events, low latency. Yeah, but after you don't need like that all the enterprise messaging capabilities on those messages. Like it's IT data. If I lose some messages, I don't really care. I really care more about having a lot of producers sending a lot of messages over, and that's where Event Grid really comes in.
Yeah, makes sense. So MQP is good for code, so keeping the quality. That's good. Good point. What I'm really interested is the manual failover. So if you said you leave to the clients if they want to decide to go in the manual failover, they can do it themselves. Although that you have installed already some automatic metric healthcare packages, say. How does manual failover will work? So do I have to program it with my own logic, or is there something else that I can do, like switching or toggling buttons or something like this?
So basically, what we are thinking, like this is still being built. So, but what we are thinking is we'll probably have, of course, to the portal, like can go to the portal and say fail over to this region now. We'll have CLI and PowerShell support. So you can just, this is where you probably will automate it, where you just run a runbook from Azure Monitor, for example. That calls a pure PowerShell script, for example. And then just one line like fail over to this region. And we are also thinking that that one is not certain yet. But we are looking into if we should also have this on the REST API.
Okay. Yeah, maybe that's also a good option if you're working with a microservice approach, something like this, then you can easily go out from your service environment and then directly.
So that's also where we see that scenario where it might be making sense to actually say, okay, you can just call this API and then it will fail over for you. Yeah. Like I said, that one is not certain yet, so that might be German private preview. Are going to get feedback on that. Might be public preview, it might be in GA. It might also be something that we either skip completely or something that might be coming after GA. depending on, and that's why I'm saying like, that's why we need the feedback, because if you think like, hey, this is a good idea, then give us that feedback, because then we know, okay, this is something that we have 20 customers ask for this, like we should build this then.
Yeah. So my personal opinion would be just to implement the REST API thing, because it stays homogenic, would say. So if you're working in that way, no, everything, any platform, any triggers you can reach by REST. And I think to make SAP Service Bus also be well implemented or integrated in your system, then REST API makes completely sense. But personal opinion. Stefan.
Eldert, is there like something like a decision matrix for which use case, which choose which service? So for example, for this take Service Bus, for this take the Event Grid or the Azure Storage Queue?
So we don't have like a nice tree for it yet. Like we have a comparison of the services. So basically compare matching services. If you Google for that, like you'll find a comparison. It is actually something that we are looking into because now with Event Grid has some new capabilities that have some overlap with Service Bus as well, like the pool capabilities, for example. So we do see that we need to have more detailed guidance on this. So it's something that I'm working on together with the other PMs about setting this up. So hopefully in the next couple of weeks to months, like we have a complete new article. And I do want to have some kind of like decision tree in there, like, okay, if you're on this kind of messages, probably use Service Bus. If you have this, to use Event Grid. Like it won't cover all the scenarios, of course, but at least we want to give some guidance. Like if you are working with IT messages, if you are working with a lot of producers with some small amount of messages, etc., like those kind of scenarios, we basically want to give you some guidance. Okay, probably look into this. So it's something that we are working on. Like there's already documentation out there that talks about like what are the messaging services, and like we talk a bit about when should you use which. But we're going to go there and make that much more detailed.
Okay.
Yeah, sounds great. Your video is a little bit frozen, but doesn't matter. Yeah, data replica. I really like that feature. So it's really cool to see that Service Bus can also replicate things synchronously and asynchronously. I like it. The question that I'm asking myself is in regard to performance. So if I go the synchronous way, I really can understand that there are some lags, something like this, in regard to the performance. But are there any, let's say, experiences or something that you can say, okay, it's you have to take into account that that's about that range or something like this, so that to get the feeling about
so of course, so for the synchronous mode, yes, you will have to think about where's my other region. Like I said, if you're going from Australia to Europe, like you're crossing half the world, just like your ping will be like about a second, and that's both ways. So that's easily 2 seconds what you would add with that, for example. What we actually are thinking of doing is basically when you set up your secondaries, that will give you some guidance about, hey, what is the average latency we see to this specific region? Like we have those numbers. We actually had them published somewhere as well on docs. So we have those numbers. Like we can say, if you're going from West Europe to North Europe, it will give you probably about this much extra latency. So we have all those numbers. So we want to basically, and we are looking to make this interactive in some way. Like for example, if you're on the portal, we want to have a. I'm not saying this will be like in the first version, but there's something we are working toward to. Similar as Cosmos DB does, you get a world map with all different regions, and you can just click on a region like I want to replicate this. That at that moment you will actually get a pop-up like saying, okay, to this region you have this amount of extra latency and things like that.
Okay. So can I also think about having kind of a cascading replication, so that I can say, okay, if I want to replicate from Europe maybe to West US or something like this, that I can say, okay, I need a little bit in between. I know there's not too much, but maybe you can say, okay, I replicate from East Europe to West Europe, then over to the US or something like this, to make it faster.
So
maybe.
No, we don't have any plans with that. I also don't think that we will do that because time it actually takes to commit on one region and then go to the next region will probably more than the added latency of actually going to the next region directly.
I think so. Makes sense. But really, I like that feature. So especially the asynchronous thing. So that again, you can just replicate all the stuff while you're working with. Um, how about guarantees that that the asynchronous replication will work and keep the messages that you already delivered? And yeah, just yeah, we are living in an asynchronous world, and maybe it's
Yeah.
eventually consistent, but maybe it is consistent.
Yeah, so with asynchronous, it will be eventually consistent, except of course, like for the failover time. So,
Yeah.
like I said, like if you set your RP for RPO for 10 minutes,
Mhm.
now let's say that your replication lag is 5 minutes at some point, and then you
Yeah.
do failover, like because your primary is completely down.
Mm.
If your primary is completely down, you do the failover. That means that we basically just lost 5 minutes of message data, which might also include things like completes and things like that. So you might also get some duplicate messages from that 5 minutes.
Okay. Yeah, understood.
Yeah.
But yeah, that's quite.
One more thing actually on that part is when you do failover, we are going to look into probably for public preview or GA, not in private preview, but hopefully for public preview, I might have this, where you can say, I want to fail over, but I want to first catch up on my backlog, on my lag.
Yeah.
So you might do this before because your primary is still working, but another component has an issue. So you may need to fail over both of them. And then you can say, okay, fail over my service bus, but first catch up on the replication lag and only then do the failover. And that would basically handle that scenario what you're talking about.
Okay.
And that one, like I said, of course, if your primary is completely down, like our data center fell over and it's gone, like then we cannot do anything. But as long as the data is still there, we will give you the option to catch up on it.
Okay. That sounds good. So hopefully data center stays. But I don't have doubts that something will go down. Another question. So I'm just taking the time. If others are running with questions, and then just put them there. Otherwise, I will continue. You said, I think just at the beginning, that you have now implemented mechanism if clients like containers. So you have often a scenario of the containers that are losing connection, something like this, get reconnect. I like it because most of the technologies are based on containers. So how is the client identification is working? So that's really interesting. So if you have multiple containers, and that's because of scale, so they seem to be the same thing, but side by side, because of mass of information transfers, and client detection could be a little bit challenging, right?
Yeah, so I don't know all the technical details because this really goes on the protocol level. But so as I understand it, like first of all, you have your authentication, like, hey, I'm this identity. So that's one part of the authentication. And that might just be your SES token or your Azure AD identity. But next to that, you also have on protocol level, you also have an identification. So basically AMQP, whenever you connect on AMQP, you get a client ID.
Yeah.
And that ID, like I said, I don't know the details on how this is being calculated, etc. But basically, when you're using this feature, that client will keep that client ID. And so when it reconnects, it will tell, hey, I'm this client ID. Here are my AD credential or my SES token. And that combined, and I think there's even another one, which is the link ID, because you connect on the same link again. But those two combined, we then know, okay, this is actually this client, and they can now connect again.
Interesting. Yeah, sounds really good. Because most of the time containers are stateless and don't know anything after they reset it. So that's quite interesting to see that this will be handled. Of course.
And like I said, most of this will just be handled by the SDK. So you don't like if you want to do this on like we have customers that actually do like raw protocol MQP connections. Those of course are taking care of this themselves. But if using our SDKs, we take care of all of this, and you don't need to know about this. You just say, I want a durable lock, and it's all taken care for you.
I like that. So it's I always call that developers' life. So everything that makes developers' life more easier.
Exactly.
That's pretty welcome. Oh, that's great. So all those nice little features that could get be implemented and are maybe in preview, maybe something in pre-preview or something like pre-GA, are really awesome to see. And because I had a long journey with Service Bus. So I use Service Bus with version 1. So it's quite interesting how it evolved over time.
Yes.
And
so actually, one of the oldest services on Azure, because I would say that about 60 or 70% of Azure actually use Service Bus. So it's one of those services like I think storage was definitely before us and VMs were before us, but I think we're like the third or fourth service on Azure. So
interesting to see, to hear, because I already installed Service Bus on my machine locally somewhere in the past, so it's that old, and I like to see what happened now. It has a touch of being an event hub on Dope because of all those features. Because now you come with partitioning and give it a little bit more space to grow and to be scalable. I really like the idea of also having Service Bus as a managed instance, completely free from everything, that you just hook up, and then spin on and leave it run. That's great. So, any others questions? Again, so I keep talking. It's just my DNA. Nope. Come on. So, yeah. I don't want to bother you all. So I really liked this and enjoyed this talk. It was really great also to see you again. It's also something that I really enjoy. But also for the others, I hope you also enjoyed everything that Eldert said. And if you, let's say, you got some point a little bit hard by understanding, or if you're not really familiar with the topic, then reach out for Eldert. I'm pretty sure that he will answer all the questions. And if you have some issues, maybe it's also the right person to put your, let's say, pains there. But I doubt that there are any. And in any case, if there's something else, then reach out for Eldert. And he offered it already. And slide decks are also that I thought you want to share it.
Yeah, I will share it on my GitHub, and I will share my GitHub link on Twitter in a couple minutes.
Perfect. That is
Awesome.
really perfect. So everyone can participate and reading the slides again. And again, it was really great to have you here. And you have a fresh morning. We have a somehow fresh evening.
Was super helpful. Yeah, I mean, you can do 20 errors in a row or 20 mistakes in a row, and if you Service Bus implementation, it was helpful. Yeah, thank you.
Perfect. Really appreciate
Really
that.
great. I appreciate that you took the time to talk with us and spend the time to just give a motivating talk about Azure Service Bus, because I think it's an underrated technology. So I have also say this because most of the people really don't see Azure Service Bus as such a huge thing that they can just keep communication and keep the quality of the messages pretty high. So I also want to state this here. Additionally, Service Bus is one of the best eventually from Microsoft. So all those that participated here in the meetup today, thank you for participation. Thank you for being enjoyable, having so much questions.